Alright, hello everyone and welcome back to the grooming course. This part is going to be all about hairs, but probably not in the way that you expect. This video is almost guaranteed to be the most boring video in the series, but I think it is one of the most important, if not the most important. Because today we're going to be covering everything that makes a hair a hair. We're going to talk about attributes, we're going to talk about the points, primitives, everything. There's not going to be any homework at the end of this. This one is purely theory, and I'm going to show you guys in examples. What I'm going to show you guys might seem like redundant information, but I promise you, understanding these basics is going to pay dividends in the long run. And because in future parts, I don't want to have to explain this every time, I'm just going to do one video on it and then have it as a prerequisite for future videos. But let's quickly set up an example scene, just so that I have something to work on. I'm going to put a grid down, I'm going to make this grid smaller, and I'm also going to change the divisions just to 3. Perfect. Let's also change the background color to dark, put an output node, name this out skin, just like we covered last video, and give it a color. Perfect. Let's name this skin. Make another geometry context and name this groom. Then we can merge our skin in here and plug in a hair gen. Name this in skin just to be clean. Give it a color. All right. So because this is just an example scene, I'm going to quickly increase the length to something like 0.2. And I'm also going to change the width. Maybe, yeah, 0.005 seems good. Also, I'm going to change from density to total count, because I only want a single hair. And then let's change the scatter seed. Oh, that was a good one. Nice and central. And then let's also give this a color. Alright, that's our setup done. Let's talk about the attributes. So in Houdini, a hair is simply a primitive made up of points. We can see this if we hit the Informations tab here. We can see what this hair is made out of. It's made of 9 points, 1 primitive, 9 vertices, and a bunch of attributes. Point attributes, primitive attributes, and detail attributes. When we generate hairs in Houdini with a simple hair gen node, it will come with these attributes, well, not color because we added it afterwards, but it will come with every attribute except color by default, which means that these attributes are important. Now we're going to go through all of the attributes so we understand what each one does, but what I want you guys to take away from this is if we have an output node, let's say we are done with our checkpoint and we say out hairs, whatever we do in between has to keep these attributes consistent. If at any point during your node graph you happen to delete some of these, you might run into issues. So always double checking if you run into issues, double checking what attributes you still have, which ones might have gotten lost, can really help you boil down what problem you are running into. So it's really important to know what these attributes do in order to problem solve on your own scenes. That's why we're covering it today. Okay, so currently we see our hair is 1 primitive. So if we were to generate more hairs, let's say we generate 10 hairs, we can see that we now have 10 primitives. That means each hair counts as 1 primitive. Let's go back to 1, and we can see that we have 9 points. On this sidebar here, we have this little button, which says display points. If we click this, we can see that we get a little indicator for where our points are. If it's a little hard to see, you can hit D in the viewport, go to guides, and you can increase this point marker size. I'm going to increase it to, let's say 6. Just to make it a little easier to see. What do we see? We see 9 points making up this primitive. One thing to realize, in our hair gen here, if we go all the way down, we have a segment count of 8, but we have 9 points. That is because the root is always going to be there. So it's a root with 8 points. Now let's get into the attributes. We're going to go through these in order from top to bottom. And in order to more easily see what the attributes actually do, we can hit this arrow up here and hit split top bottom. It will give us another viewport, and then we can hit right click on the scene view, go to inspectors, geometry spreadsheet, and here we will actually be able to see all the attributes that are stored and all the values. We have this tab for point attributes, vertice attributes, primitive attributes, and detail attributes. We're going to talk about point attributes first, so let's click on here. Let's see what our first attribute is. I'm going to hit this little pin here just so it doesn't go away. We can see our first attribute is the P attribute. The P attribute is simply the location of each point in the world space. An easy way to read these numbers is, since this is a straight line on the y-axis, as we can see in the gizmo on the bottom left here, all the values on x and z will be the same, which we can see is correct, and only the y value is going up. So all the P attribute is just the location of your points in world space. Now you might be wondering why this is important to know, and I assume whoever asked that question does not have that much experience in Houdini, because whenever you talk to someone who's experienced in Houdini, there's a certain phrase that everything in Houdini is points and attributes, and that is true with grooming as well. Everything that we do in grooming is just messing with the P attribute and other attributes, like for example, obviously the width and stuff, but mainly the P attribute. What does that mean? So if you do things like bending this hair, all you're doing is you're telling the points to move in certain directions. So we can do this, for example, if we go to our hair gen here, and let's add a mountain node, which is just a noise applied to a certain attribute. If we apply it to the P attribute, we can see that our points are now being distorted, giving us a certain look. If we lower the amplitude and maybe lower the element size, don't worry too much about this node, but let's go like really low. We can see that it's giving us a certain look. And the mountain node is not a specific groom node. The mountain node simply adds a noise to your P attribute in this case. We can also add it to other things, like we could add it to our width or whatever, but right now it's easiest if we just stick to P. So all the mountain node really does is mess with your P values. What this should show you is you are not limited to things like guide groom, guide process nodes. Those are very useful nodes, but all they do is they mess with your P attribute. This means that we have an unlimited amount of tools at our disposal to really nail the look that we need. This is also why there's not one correct way to groom, because whatever way works for you to get the look that you need is a perfectly valid way to groom. Some people groom with Vex code a lot. Other people only use the groom nodes like guide process and hair clump nodes, which are also perfectly valid. And some people just mix the two and get creative with the tools. Now all of that is pretty advanced, so we're not going to cover that right now, but the basic fundamental understanding that you need to have is that your hair is just a curve with points. And those points are stored in the P attribute, and you can manipulate this attribute in whatever way you want to manipulate the look of your hairs. That is already it for the P attribute. It is a very simple attribute, but it's good to understand how much impact this has on your hairs. It kind of is your hairs. So I hope you understood the phrase, everything in Houdini is just points and attributes, is true for grooming as well, and the world is your oyster. And whatever methods you can come up with to get a certain look are perfectly valid methods. Now that we've covered the P attribute, let's talk about the other point attribute that we have here, which is the width attribute. Now, we've already encountered the width attribute if we look at, for example, our guide groom node, and we plug our skin in here, and then let's just draw a curve. We can see, if we hit the info tab, that we have a width attribute in the details tab. Now, when I was making my setup, I actually forgot to do something, which is in this geometry context, obviously turn on shade open curves in viewport. So now we can actually change the width value, and now it works. So if I turn off my point display here, the main difference that we see between a hair and a guide is that a guide has a constant width and a hair has this nice shape to it where it comes to a tip. Now it's important to understand why this is, and this again is just because points have attributes. So if we look at our guide groom here, you might say, well, it's not the points, it's a detail attribute. And yes, this is true, but the nature of detail attributes is that these are applied on all points and all primitives equally. So you could also interpret this as the width value being applied to every point, which is why the width value is constant. So what this means is we could technically delete our width value here, and then let's say we use an attribute wrangle to quickly write in a new width value on our points, and let's also not make it this thick. And then we can see we get another constant value on all our points, and now we have a point attribute called width. Whether it's a detail attribute or you just put the same value on all points, it doesn't matter. Now, the tricky part about our hair gen and why our hair gen is coming to a tip here is that not all points have the same width value. We can see it in the drop down here. Our points start off as 0.05, which is the root point, 0.0, as you can see here. And then the next 2 points share the same value, and then the value decreases, and then coming to the tip with 0 width. Now, you might have already suspected this is exactly this ramp right here. If we were to lower this value, we can see that the values here are changing. And obviously, the look of our hair is changing. So important to know about this is that a width value on points can give you a certain look like this, and you can control that look with this ramp. Or you could make your own value, and you don't have to use this ramp. But again, we're going to cover that in the future. Right now, this ramp is a perfectly valid way to create the shape of your hairs. Alright, now those are the 2 point attributes that we have. You will notice that when we get into the other ones, into the primitives and detail attributes, that it's actually only the point attributes that dictate the look of your hairs. The p-values are literally where your hairs are and how your hairs look, and the width is like the width of your hairs. Now, the primitive attributes are a little different, but we're going to get into those in a second. First, there's actually one more point attribute that we need to cover, which Houdini does not give you by default. So let's first talk about how you actually get this attribute, which is very simple. There's this node called resample. If we drop this after our hair gen here, we can see if we visualize it and we check our points, it's currently resampling our curve. Now, if you want this, feel free to use it. You have this segment length value that you can use, or you can give it a constant value with this maximum segments, which is also perfectly fine. Or you can just not use this resampling function, and you can simply scroll down and use this curve view attribute toggle. Now, when you do this, we get the attribute curve view. Now, this curve view attribute is one of the most important attributes and one of the most useful ones. It does not impact the look of your hairs necessarily, but it is one of the best utility tools that you have. The name might be a little scary because what does curve view even mean? So let me show you what curve view actually is. If we click on here, we can visualize it. We can see that it is a ramp from our root to our tip, from 0 at the root to 1 at the tip. And this is incredibly powerful. It lets you do a lot of things, and I'm going to show you one example of that. So let's first unvisualize it, and let's go to our color node here. Currently, we have a constant color, which if you use this drop down here, we can change this to bounding box, random, ramp from attribute, and random from attribute. Now, let's check out this ramp from attribute. If you click it, it turns black because it doesn't know what attribute to use. But if you hit the drop down here, we can use the curve view. Now we can see we are actually giving this curve a color along the curve view, which is from root to tip. So in case you want to render your groom in the future, this is a good way to give color, because oftentimes hairs have a different color at the root than the tip. And now we can use this attribute ramp here to change the color of our hairs. We can even make this blue. And yeah, it pretty much just gives you the opportunity to give color to the root, the tip, and everything in between. Now, one important pitfall with point attributes that I want to cover because I think it's incredibly important to know. You need to understand how point attributes are stored on the curve. You might be looking at the 2 things that are currently ramped onto our hair, which is the color that we just added. And if you think about it, our width value is also ramped across this from root to tip, which is how this ramp here works, from root 0 to tip 1. And you might be thinking to yourself, especially when you look at the width, that whatever you change here will be perfectly represented on our hair. That's not true. The way these ramps work on a curve is currently we have 9 points, which means that it will take wherever that point is on the curve, meaning if we look at our curve view value here, we can see that we have curve view values for 0, 0.125, 0.25, and so on. This means that when you're assigning a color to a curve view value, this ramp right here, it is not taking into consideration every part of this ramp. It is only taking into consideration 0, and if we drop this down, we can enter other values. It is taking into consideration 0.125 and then 0.25. Only these, actually let me add points. 0.125, and let me actually do it this way. 125, 25, 375, and this is enough. So it's only taking the snapshot of whatever this value is, and in between here, it can't really represent on the curve. What it does in the viewport is just a linear interpolation between these points. And if it's a color value, a linear interpolation of the color values. Now that's a little hard to wrap your head around, so I'm going to show you a good example to prove that this is the case. I'm going to drop another resample node after my color, and let's make the color different. Let's actually change it to something, to a different preset, which you can do by hitting this cog wheel here. And then let's use magma. And let's also turn off our point display. You can see that this ramp here is pretty accurately represented, and we still have our width value represented pretty smoothly. So now let's go into our resample here. You can already see it kind of changed. Let's turn off the max segment length and let's turn on max segments. If I now change this to something drastic like 2, you can see the color kind of changed. And if I drop it down to 1, you can see we're losing almost every color that is in here. And you can also notice that our width is now just kind of a pyramid shape. A very thin pyramid, but still a pyramid. So what does that mean for us? If we look, currently we only have our root point at our tip point. There's no points in between, which means that Houdini doesn't know, it can't sample the ramp on anything other than the root and the tip, which is why we're losing all the colors in between and we're losing all the width values in between. So that's just something to think about. If you run into issues with your color, maybe you're not using enough points. So if I start increasing our points here, you can see how it actually changes how many colors will be represented and how accurately these ramps will be represented. So, quick recap, curve view, incredibly important, gives you a nice ramp from root to tip, and we also covered how things that are ramped across the curve are point count dependent. Amazing. Let's delete this resample node, and let's also change this to black body. I don't know, I kind of like black body. Okay, that covers all the point attributes. I promise you, if you store that in your brain, this will come up a bunch, all of these attributes. If you run into issues and you might not remember, come back to this video. This is probably the most informative video that I'm going to cover in the whole course, because this is literally the foundation of everything that we're going to build on top of. Okay, now the next attributes, the primitive attributes. First, we have an ID attribute. Pretty straightforward. Let's also change in here to the primitive tab. Pretty straightforward. ID. Let's add some new hairs. Make this 10. We can see the ID value is just an integer value that is different for every hair. So every hair gets a value that is different, so that each hair has a unique value. That's it for the ID value already. Now, let's talk about the skin prim value. This is also an integer. Now, what does this one cover? If we look at our skin prim here, we can see we have some that are 0, some that are 1, 2, and 3. You might be wondering how these numbers come to be, and for that we actually need to jump out of our groom scene and jump into our skin. If we look at our skin, and I'm just going to turn this to smooth wire shaded, and also show all objects, we can hit a button that is currently covered, this one, display primitive numbers. If we click that, it might be hard to see, so I'm going to quickly hit D, go to guides, and guide font, I'm going to put to large. And let's also make the color a bit darker so it's easier to see. Now we can see we have values here. These values are, obviously, this grid is only made up of 4 primitives, which is these 4 squares, and these 4 squares have a number associated to them, meaning 0, 1, 2, and 3. And those values are exactly what our skin prim integer displays. It is simply telling Houdini on which primitive our hair is. We can see, if you remember, because unfortunately it doesn't show if you're in a different context, this square is number 0. Let's check which one is number 1. This one's number 1, number 2, and number 3. So if we go through our list here, we can see now we also have a primitive number for our hairs. So hair 0, meaning this one, is on the skin primitive 0, which is this square. Let's go to number 7, for example. If we go to 7, the skin primitive value is 2, which is this one. Perfect. Pretty straightforward. Let's talk about the skin prim UV attribute. This attribute is a little bit more tricky, but it is pretty straightforward. It works in conjunction with the skin prim attribute. And let's use number 7 for an example again. So what do we know? We know it number 7, hair number 7, is on primitive number 2, which is this one. And then the skin prim UV value is simply telling Houdini where on that primitive the root is located. So if we go into kind of an orthographic view, we can see, if we assume that this top left corner is the value 0, 0, we can see a value of 0.15. So if we go 0.15 down and then go 9.6, 9.6 to the right, that is where our hair root is going to be located. That's all these attributes do. These two are simply telling Houdini where the primitive is. Where is the root of this hair? This is incredibly important for when you deform your hairs, maybe you even simulate them at some point. If Houdini doesn't know where this root is located, it will either give you an error message and tell you invalid skin prim attributes, which means that something about your skin prim attributes are wrong, or it will do weird things. Now, there are certain cases where your skin prim attributes will mess up. That is bound to happen. Maybe you plug in the wrong skin. Maybe you don't plug your skin in at some point during your tree. And then you plug in a node that needs those attributes to work. And you'll get an error message if I, for example, just attribute delete these two and then use let's say a hair clump. If I try and visualize this hair clump node, I can see I get an error message saying couldn't find skin prim attribute. Now, in this case, let's say I, didn't just delete them. Let's say they got lost at some point in the tree. All you have to do is use a node called guide skin attribute lookup. And this node is pretty much built to remake skin prim attributes. All it needs is a skin input and your guide input, and it will immediately remake these attributes. It will also make another one, skin query p. You don't have to worry about this attribute. If you just make a static groom, you could literally delete this and your groom would work fine. If you want to know what this is simply, let's actually look in our geometry spreadsheet. All this skin query p value is, as we can see, it's a 3 float vector, and it simply stores the location of your root point for each hair. Again, this is only important for simulation stuff, so no need to worry about it in this case. And like you can see here, you can always remake it. So if you were to delete it, don't worry about that one, but worry about skin prim UV, skin prim, and ID. Those are the important ones. Last and also least is GL shade open curves as a detail attribute. Now this is the only one that comes standard and you do not need if you follow the last tutorial correctly. Because all this attribute does is what we do if we go out of our context and hit shade open curves in viewport. If we toggle this off, we can see our hairs still show the width correctly. Now, if I go in here and I delete this detail attribute, now we can see we no longer have a width value. But if you go out here and you click this again, now we get our width value back. Okay, I know this was a lot of theory. Let's do a quick rundown of it as a quick recap. If you look at the info tab right now, these are all the attributes that you ever need to output in order to have a basic groom. Now there might be other values that you want to add to this, like masks or groups that you might want to use in shading and rendering and stuff like that. But in order to just have a functioning groom, and in order to problem solve if you run into issues like error messages or nodes not working how you expect them to, please investigate the attributes. Most of the time issues arise with the skin prim attributes, which is why I wanted to cover what they are and how you can create them. Because if you go through some grooming tutorials, they might cover, oh, we have issues with skin prim attributes, we have to remake them. But when I was learning, my question was always, why? Why do I need to, why do we need these? And what are they? Which is why I just wanted to give you the info. Now you know what these attributes are, exactly what they are used for. Also a quick side note, because I actually forgot to cover this. If we look at the skin prim values, there's a third tab, which is this one. I have never gotten a value above 0, so I assume this one is not used. If it is used, please correct me. I will happily correct myself in a future video, but for now, I only see these two values as useful. Okay, so rapid fire round. Primitives is the amount of hairs that we have. Points is the amount of resolution our hair has, and it also makes up the shape of our hairs. The color attribute gives your curves color. Duh. The p-value is the location of your points in world space. Curve view is a ramp from root to tip, starting from 0 going to 1. The width attribute gives width to your curve. That's all it does. If different points have different width values, it will interpolate between those points. Primitive attributes. The ID attribute is simply a unique integer value for each primitive. The skin prim attribute is simply an integer value representing on what primitive your hair is. The skin prim UV attribute is simply the location on the primitive where your hair is. And last, and also least, the GL shade open curves attribute only tells Houdini to shade the curves in the viewport correctly, meaning displaying width, etc. And if you made it through all that, I want to congratulate you, because understanding all that is so important. I can't stress it enough. It might not make sense right now why it is important, but I promise you, taking some time and messing with the attributes if you want to, understanding what each attribute does, will help you follow along with the course so much more in the future. This is as basic as I can make it, and I hope I covered everything in enough detail. Next video, we're going to do a deep dive on the hair gen node and all the parameters. We're going to get to more exciting stuff in a couple videos. We have to cover the basics before we get to the advanced stuff. Otherwise, I'm going to lose everyone. Alright, thank you so much for watching. Again, any questions, feel free to join the Discord, link in the description. If you have any personalized questions, that's where you can reach me the best. So, hope to see you guys in the next one, and study your theory.